Welcome to the interview with our international guest, Kirk Moloney. In the other videos, Kirk already introduced some history of point pattern analysis and his research to you. Now we're going to talk about science in general and his personal career. So Kirk, what were the most unexpected results you ever found?
Well, I must say in developing my first big simulation model, I came across some unusual results which seemed kind of interesting and not expected. It looked like it was going to be quite exciting, although a colleague who was working with me pointed out that maybe there was a bug in the program that was producing these unexpected results. This turned out to be the case, so it took a long time to fix because it was one dropped semicolon and several hundred lines of code, and it took a while to find and correct.
Well, that's unfortunate, but did it maybe lead to another research question?
Not really, but it did make me organize my code much more carefully, and then I started going line by line and debugging on the way to make sure that something didn't get buried deeply in the program that I'd have to go back to again, and it also made me be much more careful in a number of ways.
Mm-hmm. Okay, so what do you conclude from this experience?
I guess the basic thing that I concluded was it's always good to be really careful when you're doing scientific work to make sure that you've done everything correctly and not get too carried away with getting to the results really quickly, but doing it systematically and making sure that everything is set up so that you don't cause an unusual situation that is hard to interpret.
Okay, excellent. Thanks.
Yeah.
I think that's a useful message. So another question, what was your personal motivation for actually conducting your study in Iowa geographically and ecologically?
Well, again, this had a lot to do with having just obtained a job at the university. So my research had been in a lot of different places, but it was clear that it would be good to do something close to the home institution just because you can get more work done, but also because that gives your students the opportunity to work without having to travel and spend a lot of money. Also, it turned out that it was a really good place to continue developing some of the ideas about pattern formation that with the gopher disturbances, which I had worked on as a postdoc and wanted to continue because that generated a bunch of ideas that I wanted to follow up with. And prairie systems in Iowa happen to have gophers in them that are also highly active. And so it was a good sort of movement of the current research into a new setting that could benefit both me and my students.
Mm-hmm. So what are the applied applications of your studies?
Well, for the example study I talked about here for some of the videos, the applied aspect of it is that although the research itself was basically basic research looking at the interaction between gophers and how this influences the plant community, the ideas that we learned from it about how that process works in a natural system can be used to help in restoration and in reconstruction of prairies. Iowa is a place where only 0.1% of the prairie remains, even though people didn't come and start plowing up land in the state until the mid-1800s. So it's a totally re-engineered environment, and a lot of people now are trying to restore prairies, and it's a very hard thing to do, and learning more about the ecology can help be more efficient and more successful in doing that sort of thing.
Okay, thanks. Very interesting. And more generally speaking, so how did science in the US or in general change over time? Was it easier or better in the old days than today?
Well, it's, I don't know if you could say it was easier or better, but it was definitely very different. So when I started studying ecology, it was basically a discipline where people worked on their own. There was not much collaboration. Most of the work that was being done, people searched for pristine systems that had as little human impact to learn something about natural systems. But as time has progressed, questions have become much more applied, and also it's much more common to have have collaborative studies. For example, my first papers, I was the only author. Now I would say on a minimum it's 5 people authoring papers together. So that's a really big difference. Also, there's been a fairly big move towards more applied research. And this is because we've answered quite a few of the questions in a natural setting. So it's a general way to try and use those ideas. But also, I would argue that a lot of it has to do with funding. Mm-hmm. And now agencies have to show to the public and whatever that the money that they're using has some practical application. And so that's fed into what people do as research. You have to have some applied component of it, most likely, to be able to be successful at getting funding. And so that's been a big shift.
Yeah. Okay. And would your latest paper, for example, would that have been possible in the 1990s?
Well, that's an interesting question. I think I'll start by talking about the paper or the study I did here, which was done in the 1990s, so clearly it could have been done then. But the studies I'm doing now that use sort of point pattern analysis techniques and the like could not have been done back then, but it's more in terms of the amount of detail we can learn about the system and the difference between small scale and large scale processes and linking them together. Back in the 1990s, we didn't have the computational tools and also the statistical tools that could get at that more fine-grained information and could integrate across scales. And so that has definitely changed. So in my latest paper, no, we couldn't have done it back then. We could have done similar research, but the findings would have been less complete.
Mm-hmm. Okay, so what was actually the biggest challenge in your career and how did you deal with it?
Okay, well, the biggest challenge came about because when I was a postdoc at Cornell University, I was doing modeling work and all of this was very computer-based, and I had my computer stolen from the office as well as all the backup tapes. So the model was almost complete, if not totally complete and working, but I had to start rewriting the code again. It was easier because I knew what I wanted to do and how I had done it, but it would be really boring just to write the same thing over again. So I switched to a different language, moving from Pascal, which the original model was in, which was a language that had actually been developed to learn how to program and wasn't a really great program for doing complicated, time-intensive sorts of research. C was a much better language, so I was able to rewrite the program and teach myself C at the same time. So I felt like I was actually not wasting time that wouldn't have been wasted other than having the computer stolen. So that was actually, in hindsight, a really good thing because I still program in C++, and this gave me the foundation to be able to do that.
Yeah, but still must have been very tough at the time.
Yeah, it was very tough, and in fact, it gave me some problems in trying to get tenure because it delayed a major paper because I had to spend about a half a year, if not a year, reprogramming without publishing.
Oh, well. Now turning to the future. So what do you foresee for the future?
Well, sort of going back to the idea of scale, I think with the new technologies and the new statistical tools that we get, I think the future of ecological research is to keep broadening the scale that we consider with really fine-tuned knowledge about the processes and how they scale up. And so the new techniques using drones and the like will allow us to get fine-scale information over a really broad scale. So we can start linking from centimeters up to maybe kilometers potentially in the near future. Whereas when I started working, basically most studies in plant ecology focused on scales from several centimeters up to a square meter, and that's where the knowledge was. As I continued working, that went up to 80 to 100 meters, like in the gopher study. And now the last project I did was maybe 200 by 200 meters, but more detailed knowledge at the small scale, linking to the large scale. With drones and the like, I would guess we can go from centimeters to square kilometers potentially in the near future, and that will be a big insight into some of the bigger problems we have today in ecology.
Okay, thanks a lot.
Yeah,
And thanks a lot for your interview.
Thank you.